Use your graph, that's the graph we plotted in previous question, to calculate the rate of the reaction at the start of the experiment. Be sure to include a unit. Okay, so just to remind ourselves, we had some data from a previous question of a reaction between magnesium and hydrochloric acid. It produced hydrogen, and that's what we want to calculate the rate of that reaction. So this question here was about C, so forget that. We're talking about this curve here. Okay, so what we need is a ruler. This is a curve, and we need to calculate the gradient. Okay, the gradient at the start of the reaction, it says here. Okay, so the start of the reaction is down here is 0, and we need to put our ruler on that curve right at the start and draw a tangent. In other words, make it into a straight line. Okay, so that's what we're going to do there. And we need to do this in a pencil, really, ideally. Draw a nice ruled line. There we go. Okay, so now we need to calculate the gradient of that line. So the gradient of a line is the difference in the y-axis. That's certainly what I was taught when I was a kid. If your maths teacher has a different way of explaining this, then by all means calculate the gradient of this straight line as you would in maths. But my teacher told me difference in y-axis divided by the difference in the x-axis. So we've now actually come straight into a maths lesson, haven't we? Okay, so the y-axis. Y-axis is this one up the side here. We need to be sure of the scale on here. So it goes 0, then 10 squares is 20. So every little square is going to be 2. So let's. I'm just going to. What we need to do is basically just pick a couple of points. So I'm going to make it easy for myself. I'm going to pick 40 on this x-axis and draw a line up to our straight line here, okay, wherever it hits that straight line. And then we're going to draw it going across where it hits that straight line onto this y-axis, so there. And that's the y-axis bit we need to read off. Okay, so every little square is 2, so that's one little square beneath 40, so that's 38. So 38 is my high point, 0 is my low point, so 38 minus 0 is 38. Now exactly the same for the x-axis. We drew up from 40, didn't we? I made it easy for myself by going at a nice, going at one of the thick lines, so 40 minus 0. And once we've put that into our calculator, 38 divided by 40, we're going to have our gradient. So let's do that. 38 divided by 40. 0.95 equals 0.95. Now the question said be sure to include a unit. Okay, so we need to figure out the unit. We need to go to our y-axis, which was centimetre cubed. Okay, so that was centimetre cubed there, wasn't it? We need to go to our x-axis, which was seconds. That was seconds there. So we've got centimetre cubed divided by seconds is our unit. Now we don't say centimetre cubed divided by seconds. We should say centimetre cubed per second. Now if you're doing the Edexcel specification, you write per with a -1 after the seconds. That minus there, -1 there means per centimetre cubed per second. If you're doing the AQA unit, they tend to write it 0.95 centimetre cubed, and they actually use the divide slash by seconds. So it means the same thing. It doesn't matter which way you write it, as long as you write centimetre cubed per second. I should quickly say actually that because you've drawn your tangent from your graph, and there's a little bit of a little bit of difference in the way we draw our graphs, there will be some flexibility in this answer. So if you don't have exactly 0.95, something say between 0.9 and 1, then probably that's absolutely fine, because we're all going to draw our graphs slightly differently. All these questions and more on ayleshamhighchemistry.com.